Okay, let's correct our math spiral for Thursday, April 2nd. We're doing day 4. Okay, draw hands on the clock to show 9:10. Shorthand is the hour. I'm going to draw that one going towards the 9. And 10 minutes, I'm going to start counting 10 minutes around. 5, 10. Right here at the 2 would be 10 minutes. So a long hand pointing at the 2. Okay, we went to the circus at, well, what time does that show? Let's look at our shorthand first. That's the hour. It's pointing at the 11. And I'm looking at my minute hand. It has already passed this side of the clock, and it's reached the 12, so it is 11 o'clock right here. It really is 11. In fact, since it's pointing at that 12, that is exactly 11 o'clock with 2 zeros. Okay, would that be AM or PM? Okay, you wake up around 6 or 7 AM. It doesn't turn PM until lunchtime at 12 o'clock noon. So would it make sense to go to the circus right before lunch? Could that be a good time to go? Yes, that could. We're going to say AM. 11 o'clock p.m., you're probably in bed because you usually go to bed around 8 o'clock p.m. Okay, here we have a triangular prism. If we remember, a face is the flat side. Hold on one second. I'm going to grab my triangular prism really quick. Sorry about that. Okay, here is a triangular prism. It makes this triangle shape on one side, and it's 3D here. Okay, if we remember, faces are the flat sides. Okay, so in the drawing, we can't see all the faces there. But in my real one here, I can see that there's a flat on this side and a flat on that side. So we know that there's one over here that they are not, they can't draw that. You can't see that. So there's 1, 2. We also know that there's one on the bottom. They can't draw that either. But there is one here flipped around. So there's 1, 2, 3. And there's a flat on the front and on the back. There's a face. Again, they can't draw that. There's one back here too. There was one on the bottom. So the drawing, you can only see 2 faces, but there's much more than 2 if you were to hold one in your hand. So the total number of faces, we have 1, 2, plus the bottom, 3, and now the 2 sides, 4 and 5. There are 5 faces. Okay, vertices are all of those points that the lines come together at. So there's one point here in the back where they all come together, one in the front when they all come together, down at the bottom. Okay, on the opposite end, there's one back here that you can't see, they can't draw. We know it's a triangle on the back side too. So there's one that you can't see. So 3 on the front, 3 on the back. 1, 2, 3, 4, 5, 6. 6 vertices. Okay, now the edges. Those are these lines that go across here. Okay, we have 1 on the top. Now on each side here we have 1, 2, 3. On the back side it's going to be the exact same. 1, 2, 3. So what's 3 plus 3? That's 6. Plus the 1 on top, that's 7. But wait, we also have our bottom. Look at the bottom of the triangular prism. What shape do we have? Yeah, we have a rectangle shape. We have 4 more edges here. So we were at 7, 8, 9, 10, 11. There are 11 edges on a rectangular prism because there's this line back here on the bottom that you can't see in the drawing. Okay, and the name of this shape is called, sorry, not rectangular, it's a triangular prism. Triangular prism. Okay, you have to imagine the 3D shape when you're coming up with the edges and the vertices and the faces. Okay, partitioning a rectangle. I know I have to do one number less than what it shows. So if it's 6 rows, I know rows are side to side, I'm only going to draw 5 lines. So here we go. 1, 2, 3, 4, 5. Okay, let's double check. Do I have 5 lines? 1, 2, 3, 4, 5. Yes, 5 lines going across will give me 6 rows. Now, 3 columns. I'm only going to draw 2 lines going up and down. Columns are up and down. So I need to kind of make it even. I'm going to do 1 here and 1 there. Okay, this is your multiplication problem. 6 times we're going to add the number 3. Because look at, we have 1, 2, 3. 3 boxes, plus 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 3 boxes. We're adding it 6 times. So let's count by 3s. 3, 6, 9, 12, 15, 18. We have a total of 18 boxes. So 6 times 3 equals 18. And on the last one, our fractions here. Joe colored 1/3 of his circle. If we remember that 1 means the first number of your fraction means 1 piece out of the 3. There are 3 pieces altogether. Your bottom number is called the denominator. And that means how many pieces you have all together. And the numerator, that's the number on top, tells you how many pieces you have. So 1 is shaded out of 3 pieces. So which one of these has 1 shaded? Okay, these two have 1 shaded. But what is the total number of pieces? This one has 1, 2, 3, 4, 5 pieces. So this fraction should be 1 out of 5. This fraction is 1 out of 3. 1 is shaded, and there were 3 pieces total. This is 1/3. Okay? This one had 3 pieces, but 2 were shaded. So this one's called 2/3 because 2 are shaded. 2 out of the 3 pieces are shaded. Here it's 1 out of the 3 pieces, and this one has 1 out of 5 pieces. Okay, good. So tomorrow before you take your test, I have not taught you what quarters means. Okay, so I want you to write this. Quarters equals fourths. So you're going to mean, quarters means 4 pieces. A quarter is when it's split into 4 equal pieces. Okay? You haven't learned that yet, so I don't want you to miss that on the test for tomorrow. I will see you work tomorrow.